Hello, this is a video for SOEN6441, Advanced Programming Practices. This is for week 4. So today for this video, I'm going to present the build number 1 requirements for the project. So the build number 1 is here. So let's go with this. Okay, so this is essentially some kind of grading scheme I'm giving you. So it's giving you the list of requirements, all the things that are required, that are worth grades for your build. So every requirement is listed here, and the marks associated with each is given here. There will be a marking sheet that is going to be available later, probably a week before the presentation. It's going to be made available to you, but it's going to respect the same grading breakdown that is presented here. Essentially, here there are things you must do, and also some of them are requirements of the software. But some of them are also evaluation of how you're doing, for example, in the presentation itself. These are the functional requirements of what you must implement. And there's also some other requirements or tools or marks that are associated with the tools that you are using. So I'll come back to that later. So for example, there's 5 marks for your presentation overall. There's 30 marks for all the functional requirements that you must implement. And then there's 15 marks for evaluating how well you are using the tools as you are doing the development, for a total of 50 marks. Let's go back to the introduction here. So essentially here I'm presenting you a build, requirements for the build. So you have a few weeks to actually implement this build. So that's normally how it's done in incremental software development. One thing that is normally happening when you're doing incremental software development is that you have first to define what you have to do in the build. So here I am myself providing you with that so as to make sure that everybody is doing the same thing and that everybody is graded according to the same criteria. Normally in real life, first step would be actually to determine what is it that you will do in this build in collaboration with your client or your boss. So you will have to do a presentation. Very often also when you do incremental development, when it comes to the time for the delivery, of course, you have to deliver. You also have to do a presentation for whomever you are doing this project. So this is how it's going to go. So at the due date, it's going to be, actually, I'm going to provide you with a schedule. And then every team is going to have to choose a time slot in the schedule. And then there's going to be 3 different markers associated with the marking of the presentations. Then you schedule a meeting with one of the markers. And then at the time that you have selected, you go there and you do a presentation of your build. Okay. The main thing about this presentation is that you are demonstrating on the computer that the software that you have developed is actually doing what is listed here. Okay. It's not a presentation about you're having a PowerPoint and you talk and so on. No, it's about going over the list of things that were asked from you, and then you share your screen, and then you somehow demonstrate that the software is actually able to do what was asked from you. Okay. You may have a PowerPoint if you want, but the main most of the time you will spend during this presentation is basically running the software and demonstrating that it's actually doing what was supposed to do, what was agreed that it's supposed to do. So you should start with a brief presentation of what's the goal of your build, then a brief presentation of the architectural design of the project. How is it organized and so on. Okay. There's not going to impose that you have, I'm not going to give you very strict restrictions as to how software should be organized. So it's going to be somehow up to you how you organize it overall, like architectural design. Next week, I'm going to actually propose to you that you use MVC, but you don't necessarily have to use MVC. That's just what I'm proposing, and it's not going to be that you have to use that, though it's a very good candidate for software like this. Then you go and demonstrate the functional requirements as listed on the grading sheet. So I propose that you actually go sequentially over the elements of the grading sheet, as I will present later. And then as you go, then the marker will also go over the list of tools that you're supposed to use in the project. Okay. So you will be graded as to how effectively you can demonstrate the features. So if there's a lot of struggle and confusion as to how the presentation is going, you may lose some marks. You will also often have to explain, like go in your code and explain how something is implemented. If you struggle with your own code or you're trying to explain how it works and you're struggling, then you may also lose some marks also. And before you start the actual presentation, you have to submit your code on Moodle. There's actually a due date for that that's going to be set. So first of all, as I just said, there's 2 marks for effectiveness and structure and preparation of your presentation. So if you struggle during the presentation as to what to do next, you might lose some marks. So it should go very smoothly. The more smoothly it goes, the less probable it is that you'll lose marks for that. Okay. So that requires preparation, of course. Perhaps a rehearsal that you do with your teammates. And then when you are asked to explain things, for example, how you implement some of the requirements there, you'll be asked to go in the code and explain. If your explanations are not clear, then you may lose some marks also. Why is it important? Because communication is a very important aspect of software development. As you discuss with other people, you try to explain things to other people. It's very important that you be able to clearly express yourself. Okay, so that's why it's actually part of the marks. So let's go to the functional requirements. First, there's a note here. Note that here 30 marks means this is the total marks for the functional requirements. Okay, so there's a total here. Those that are bold are totals. So this is a total of all the functional requirements. This is a total of all the map editor marks, and so on and so forth. So those that are bold are just a total. The functional requirements, total of 30 marks. Game must include a command prompt that is available throughout the game, even if you have a GUI. So there must be, somewhere on your interface, or if you're using the command line of your IDE, or there must be a way for the user to actually enter commands. Okay, and the commands I'm describing here. Okay. Even if you're using a GUI, there must be a place where the user can enter commands. So of course, when you're going to use, the user is going to use the GUI, it's going to somehow create some actions. So that's fine, but you must also allow the user to enter commands that will actually do the same things as the user is entering, for example, clicking on things and so on. I repeat again, I'm going to repeat that very often. You don't need to have a GUI. The whole thing is expressed so that you actually don't need a GUI. So If you have a GUI, you're not going to have more marks. If you don't have a GUI, you're not going to have less marks. Okay. Of course, it might be more interesting to you to make it with a GUI, but the point is that it may be more work. And also, I'm not explaining in this course how to do GUI, so I cannot ask you to actually do that. GUI development is not a requirement of this course. But again, you know, here where the topic is a game, it's not either a game development. So what I'm testing here is whether or not you can produce code as a team while using the tools that I'm telling you to use. Okay. So that's what it, and using the incremental software development method. Doesn't matter that it's a game or not, or if it's a GUI and it looks nice, that's not the objective. The objective is that you develop code as a team using the tools that I'm telling you to use. So first is you have to develop a map editor. Okay, so thing is that you have these domination files that we talked about before in the game in the project description, and we had a lot of discussions about these kinds of files. So yes, you must be able to read these files, but also the user should be able to create a map by interacting with your software, or load a domination file and then using commands basically change what is the map that is stored in the domination file. So it's not acceptable, for example, that your map editor is just you're opening the domination file in a text editor and then you edit the file. Okay, you should have user interaction using these commands I'm describing here. So first, there should be a user-driven creation or deletion of map elements. For example, creating countries, continents, and connectivity between the countries. So those of you who have seen the domination file format, then you have the continents, the countries, and the neighbors. So using these commands here, you'll be able to add or delete continents, add or delete countries, and add or delete neighbors between the countries. Okay. It's important here, as I'm stating here, each of the commands should only work in the game phase for which they are designed for. For example, these commands here should only work as you're editing a map. For example, if you're playing the game and the user enters these commands here to edit a map, they should be rejected. Okay. The user should be allowed to enter them, but they will be rejected. So anytime, for any command that I'm listing here, they are only valid in a certain phase of usage of the game. Okay. The commands should use exact same syntax as defined below. You're not allowed to change what is the nature of the commands or add or remove commands. Let me create myself. Oh no, I don't have a pointer. Okay. Some commands have options preceded by a dash. For example, edit continent dash add and then dash remove. Options may use from 0 to multiple times. These options may be used from 0 to multiple times in a command. For example, you can go edit continent dash add and then the continent ID and continent value, and then again dash add to add many continents in one command. Okay. Or I can go edit continent dash add, and then add a continent, and then dash remove to remove another continent. Okay. I could even remove as many continents as I want in the single command. Okay. Okay, so I can add or remove continents, add or remove countries, add or remove neighbors. So you see this is for 2 marks. So these are the number of marks associated with each of these requirements. Then I can display the map as text that's going to be shown in the command prompt. Okay. So this basically assumes that this is kind of a command prompt. And then if you type a command, then it may display some things as text. Okay. So if you type the command show map, then it should somehow display the map. So it's up to you to figure out how you will display a map, but you must be able, when you type show map, that it somehow displays the map as text. And then you can actually save the map using a file name, so that if you create a new map or edit an existing map by loading it and then creating some commands to edit the map or change the map, then after that, if you go save map and then the file name, it's going to write the file to on the computer, the file system of the computer, using the domination file format. Okay. So that it can be loaded after, and also that it can be loaded by your game. Because that's the objective here, that you create yourself maps so that you can play on these maps on the using the game. Then you can also, in the editor mode, you can actually go edit map and then a file name, which will actually load an existing map, then load this map so that you can actually create commands to actually change this map. Then eventually, of course, saving it as changed. If you go edit map, a certain file name, and this file name does not exist, then basically that means I want to create a new map. Then you have a command to validate a map, because you don't want to allow the user to create a map that's not playable. So by typing validate map, it would call a method in your implementation that will check if the map is playable. So I'm going to let you figure out what are the criteria by which a map is playable or not. So that's it for the map editor. Okay. Then when you play the game, so there must be some class named game engine in your implementation. And this game engine class is actually controlling the flow between the phases of the game, okay, and then somehow controlling how the game is going. We'll see more of that when I describe the other requirements thereafter. So yes, there must be a class named game engine, and this game engine class is responsible to control the flow of the game. During any time during gameplay, then you can type show map, and then it actually displays the state of the map as it is right now. Note that here I also had show map, but this is show map during map edition. For example, during the map edition, there's countries, but countries during the map editor phase, the countries don't contain armies, and the countries are not owned by players, because in the map file, there's no notion of armies and players. Okay, it's just a static map that is not being played on now, so armies and players don't make sense. However, if you during the game, if you type show map, then it actually shows the current state of the map as it is being played. For example, showing what is the number of armies on each of the territories and what is the ownership of each of the territories. Then, so that's a command that you can use anytime during gameplay. Okay. Then you have what is called the startup phase, which is the phase that happens after you load the map and before the actual game is being played, which is called the main game loop. So this startup phase starts by having the user determine which map they want to play with using the command load map and then the file name of the map, which should be the same files that you have created here, or any pre-existing domination file. So the user should be able to play on any map you've created or any map that's already a pre-existing domination file. And this command is a startup phase command. So once you go to the other phases, you should not be allowed to load map again. Okay. Another startup phase command, so you should be able to add or remove players because you want to be able to play the game, so you have to add the players. Then after you've created all your players, then you can type the command assign countries, which is going to assign all the countries in the map to one of the players. Now here I have this requirement here is quite verbose. It's basically giving you some kind of idea of how it should work. Okay. It's very important that you implement it as I'm describing here. You may have another idea of how this should work, but you have to implement it as I'm describing here. Why am I describing this? Because in the further phases, I'm going to add to this, and it's going to suppose that you all have implemented it using this model of execution. Okay. So yes, I'm giving you some restrictions. Whatever you're not restricted with, what I'm saying here, you can do whatever you want. Okay. So there must be a player class. So there must be a class named player that is representing every player. Every player is an object of the player class in the game. So the player class must have a list of country objects that are owned by the player. So every player has a list of countries where the countries are the countries that are on the map, that are owned by this player. It also has a list of order objects. So you see I have anything that is starts with a capital letter here. This is classes that you must have. Player class, country class, order class. Order objects that have been created by the player during their current turn, and has a method issue order. So the player has a method in it that is called issue order. It has no parameters, no return value. What does it do? It actually adds an order to the list of orders held by the player. And when is, or by which other object is issue order called? Issue order will be called by the game engine during the issue order phase. Okay. So during the issue order phase, the game engine basically will call issue order to each of the players in round robin fashion until all of them said, I don't have any more orders. Okay. So you see that I'm giving you the restrictions as to how this thing should be organized. Again, you must abide with these restrictions, and whatever I'm not restricting you to by my requirements, you can do whatever you want. And then the player class must also have a next order method that has no parameters and that returns an order from the list of orders of this player. So it basically returns the next element of the list of orders in the player class, in the player object, and then removes this order from the list of orders of the player. So during, and this will be called by the game engine during the execute orders phase. Okay. So that's the restriction as to what the player should be and what the player must hold and what kind of methods it should have. Okay. And this, you see, I'm giving 4 marks for that. Then there's the main game loop. Okay, so main game loop is basically consists of 3 different phases. Okay. Then I'm giving you 1 mark for the fact that you must have a loop to loop over each player for the assign reinforcement, issue orders, and execute orders main game loop phases. So as the main game loop is happening, there should be 3 phases. Assign reinforcement, issue orders, and execute orders. During each of these, every player is given a turn. Okay. For the assignment reinforcements phase, so that's where at the beginning of their turn, a player is given a number of armies. Okay, so I'll let you look into the rules as to what is this number of armies. It essentially depends on the number of countries they own and possibly the continents that they also own. Okay. And this is done only once at the beginning of a turn in the main game loop. Okay. And is done every turn. Okay. Second thing that happens during a turn is the issue orders phase. In this turn, in this phase, what happens is that game engine will call the issue order method of the player. For every player in the list of players, it will call issue order, issue order, issue order. And then as a result, every player, when you call issue order, it's gonna create an order and then put this order in their order list. The issue order method will wait for the following command. In this case, we're going to have only one, for build number 1, we're going to have only one possible order, which is deploy. Eventually, we're going to have more orders, but that will be in the upcoming builds. So as the game engine calls issue order on the player, then the implementation should actually be waiting for the player to type a deploy order. Okay. If you are using a GUI, then maybe it's waiting for the player, for the user to actually click on something to actually deploy their armies and so on. But even if you have a GUI, you must still allow the user to enter the command as text. As this is a deploy order, you see what's happening here is that as the player was given armies in the assign reinforcement phase, the player is given a certain number of armies that they can then place on the map. Okay. Every time the user, the player creates a deploy order, let's say the player received 10 armies for the turn, then the player can say, deploy 2 armies on the country Canada. Okay. Then the effect of this order is eventually that the country Canada will have now 2 more armies, and then 2 armies will be deducted from the reinforcement armies that the player had received for this turn. So the player will be allowed to create many deployment orders until they run out of reinforcement armies for this turn. And then the game engine will call issue order to each of the players, in which they will be allowed to create a deploy order. And then this will run until none of the players currently have reinforcement armies still available. So that's it for the issue orders phase. And that's only one order that is valid in this particular phase. Now then after, what's going to happen, because at this point, the players have only issue the orders. The orders have not been executed. Okay, so these orders are now stored in each of the player's order or list of orders that are stored in the player. Then what's going to happen is that the game engine is going to ask the player, give me your first order. Then do that for every player until all the players have run out of orders. Okay. So there's issue order, which is then followed by execute order. Players all create all their orders before any of the orders are being executed. So once all the orders have been issued, then you go to execute orders. So you see here that there's no command associated with that. Why is it? Because it runs automatically. It does not depend on user interaction. In this case, the game engine basically calls next order for each of the player. Player number one, next order, gives them an order, and then the game engine calls the execute method that should be inside of the order object. Then the effect of executing a deploy order is to place the number of armies on the territory or the country that is associated with this order. So if, as I said before, the player had said, I want to put 2 additional armies on Canada, then when the game engine executes this order, then the order, it will call the execute method of the order, which will then place 2 armies on Canada. So this information about where the number of armies should be added, as well as the number of armies to be added, should be stored inside of the order itself. Okay, don't assume that these are parameters of the execute method. Okay, so the order class must have an execute method that will be called by the game engine when they want to execute the order. Okay, now you may, I hope you see that there are lots of things I'm not saying here. Okay, so the point is that, as always, that you figure out what is it that I did not say. Because if you try to implement this and you only base yourself on what I just said, you'll see that there are many things I didn't say. So first job is figuring out what is it that I didn't say, and then we can have discussions during the live lecture time. Now that was it for the functional requirements. Now, what about the use of the tools that we had defined in the previous lectures? Well, some of them are not tools. For example, architectural design. So if you remember in when we talked about extreme programming or incremental development in general, we said it's very important to have a global idea of what is this project. Because when you do a build, then you focus on a small subset of what needs to be implemented. It's important as you work on a small subset that you're not just blinded by the details of this subset and then you forget about what's the big picture. So this architectural design that I'm asking you there is about writing down what is the big picture. So the big picture here comes into architectural design short document. Very important you understand, I'm not expecting a large document. I would say one page for a diagram, an architectural design diagram, and then another page that describes short description, text description of every module in your implementation. Here, it's not because the mistake that some of the students or teams will do is to say, oh, he's asking for a design diagram and then provide me with a very detailed design diagram. No. Architectural design diagram shows There are, for example, 3 modules in this implementation. For example, if you're using MVC or Model View Controller, then what you'll have is Model View Controller. Just describe the different modules in the implementation. Then you describe what is model, what is the role of the model classes, what is the role of the view classes, what's the role of the controller classes, for example. So this diagram should only describe what are the different modules and what is the role of these different modules. Eventually, also, if you have defined modules, I also want to see in your folder for your code, there, for example, you have 3 modules, you should have 3 folders, or should be organized. The code should be organized accordingly to what you define in the architectural design document. Then second, software versioning repository. So you should have dozens of commits. I'm not going to say a specific number, but you should have dozens of commits. Okay. They should be distributed evenly among team members. So I don't want to see that one team member has 50 commits and then all the others have like 5 and one has just 2. Okay, that's what I want to see, is that there's an even number of commits across people. Okay. Of course, I'm not expecting that's going to be exactly the same number, but don't come at the demo and then some of the teammates have like 3 commits and others have 50. And also that the commits are well distributed over time. That the commits are not just done 2 days before the actual delivery of the build. There should be a tagged version that has been created for build number 1. Also, you should use a continuous integration solution that is doing the 3 following operations. Every time you push, there should be operations that would be triggered. These operations are that the project should successfully compile, all the unit tests are successfully passed, and the Java doc is compiled and is reported as complete, as I explained in the lecture for that. Then there's your API documentation. That's essentially your Java doc. The Java doc should be there for all files and for all classes and for all methods of all classes. Okay. Then for the unit testing, you should have, for the moment, at least 10 relevant test cases. So 10 is a very small number. What I want for now is that you take you get used to develop test cases. For those of you who know how to do test cases, you would know that 10 test cases is kind of a ridiculously low number of test cases. But what I'm expecting for now is that you started using test cases. So there are some test cases that I'm imposing. These are, first of all, map validation, that you check that the map is a connected graph. Second, that you validate continents, that the continent is a subgraph, a connected subgraph. Third, you should test the calculation of number of reinforcement armies in the reinforcement phase. And fourth, that the player cannot deploy more armies than there is in their reinforcement pool. For coding standards, you should use consistently the coding standards as described below, which is what I explained in the lecture for coding conventions. I'm not going to go detail here. So basically, there's naming conventions, there's layout, there's commenting convention, and there's the project structure. So this is worth in total 15 marks out of 50. And then there's 30 marks out of 50 for the functional requirements, and then 5 marks for the quality of your presentation. So that's about it for this presentation.